didn't make it far enough that I felt comfortable doing a daily quiz of the normal variety. Instead, we're going old school. Let's see how well you do without a calculator. Oh no! That. 3/4 plus 5/12 plus 3, oh, 3 by 1/6 plus 3/4 by 1 1/2 is 3/4 Z. Be not afraid of the fraction, young one. Remember your training. Common denominators, remember? It is common denominators simplify what is on the left-hand side, solve by one inverse operation. I just want to see if you can do it. Adding and subtracting fractions was first introduced what? 3rd, 4th grade? Definitely beat the snot out of it in middle school. It's just whether you actually did it or remember it. Because often we get partway through middle school and then they start letting us use a calculator and then we just forget how fractions work. I just want to see what you can do. What's that? 4 and 5. 4, 12, 2, 8, 5, 24, 18, 10, 12, 40, 49, 27, 27, 27, 24. So, 24, so 5. Let's cancel 6. 6. So that's 6, 7, 18. Or 26, 54, 3, 13, 18. Do you remember how to get common denominators? What if I sweeten the pot and say, you know that I do donuts on Fridays? You get it right without that calculator. Maybe you get to come collect your bounty Friday morning. Why? What? Why do you have so many chairs? Anyone think they're sniffing down the right trail? No? It ain't pretty when you're done. Remember old school? To get least common denominator, you have to find the least common multiple. Anyone? Ew. We don't talk about decimals. Decimals are yucky. Decimals are not accurate. Okay. First things first, you make them all fractions. Some of them got a little bit of multiplication going on. Others have mixed numbers. Do you remember how you turn a mixed number into an improper fraction? Okay, multiply and add, right? If I'm in halves, I'm saying I have one whole thing of halves. So there's two halves. Plus one left over. So that's 3/4 by 3 halves. How do I multiply together? Straight across. So 3 times 1, 1 times 6. Okay, multiply anything you can, simplify anything you can. We've got 3/4 plus 5/12 plus 1/2, remember? Plus 3 by 3 is 9. 4 by 2 is 8. Is 3/4 z. So you look at all your denominators and say, what is the smallest number that 4, 12, 2, and 8 all go into? No, go into 24, right? The 12 is what threw it off. So, in order to get that, I need to multiply this by 6 by 6, by 2 by 2, by 12 by 12, by 3 by 3. Okay? Now, all those denominators are going to be 24. So if they're all 24, then I have all that junk over 24. I'll have 18 plus 10 plus 12 plus 27 . 18 plus 10 plus 12 plus 27 is who much? besides woefully not enough? Ooh, it is 67. Remember, there's a trick with compatible numbers. Smack those two together and you get 30. 10 plus 10 plus 8 and 2 is 10. So 30, 40, 67. 24ths, which can't be reduced, by the way. Okay, you get all the way down there. How do I get z by itself? And dividing by fractions, I hear it's easy. Almost like pi. What do? Flip second multiply. Okay. So multiply this by 4/3. Cancel, cancel. Cancel, cancel. By 4/3. If you can cancel any part of it, do so. There's a 1, there's a 6. They both divide by 4. And I get 67/18, or 3 13/18, or about 3 and 40-ish minutes of sleep. This was last night. I'm just saying, be gentle today, because that was literally my sleep schedule last night. 45 minutes, wake up, deal with sick kid. 25 minutes, wake up, deal with sick kid. Hold sick kid on couch so sick kid can sleep upright because he's choking at his own snot. 3 10-minute, I passed out partially. Eventually get kid back in bed for an hour and a half, but fits and starts, so we'll only say 3/4 of it. If all of that is running at about 3/4 efficiency because the kid keeps making noise on the monitor, then you have about a grand total of 3-point-something hours. Parenting has pros and cons. Pre-calc wrecked me today for brownie points because I can't add 2 plus 5. I'm pretty sure it's 11D blue. So, if I make some goofs, stay on the ball. You might get me. We were actually very, very close to done yesterday. Oh no, I just wanted you to get some practice with fractions because y'all ain't good at fractions. No. We're kind of sketchy at fractions. I just wanted to get a little practice in there and say, hey, be nice. So,
What about our assignment from last class?
We didn't have one.
Oh.
And we didn't have one last class. Oh wait, yeah, that's right. We did. I just never put it on plan book. Okay, it was just that little bit of review, right? 38 through 47 at the end of that page. Thank you. I forgot to put it on plan book. I put it on remind. I didn't put it on plan book. Did we have any questions about it? It was a nice little spiral review of this is stuff that we've done this chapter. Was there any of it that was a little sketchy? Just wanted to double check something? Yeah?
40.
Okay. Yeah, I don't even have it queued up here. Okay, words. Sal's Supermarket sells cases of 24 12-ounce bottles of water for $15.50. Shoppers World has 12 packs of 12-ounce bottles, so they're selling the same thing, except this guy's 24 for $15.50. This guy's 12 for $8.15. Which one's got the better price? Y'all remember setting up proportions? The Jesus fish thing, right? You loved that. I showed that to my pre-calc today, and they swear they'd never seen it before. Like, they've always just cross-multiply and then divide the hard way. but they've never just seen multiply then divide this. How did you get to pre-calc never seeing that? Y'all in algebra half, and I think that was the best you ever did on a test. So we have 24 per pack at 1550. Can't even write straight. And then we had a 12 pack at 815. Y'all never seen that with the book or with the boards? See, if I'm writing over here and then I decide to write over here, it'll like average the middle of them. No? It's fun. Okay. These are both ratios. If I want to know what's the better deal, I want to know which one has a better price per bottle. And the wording right there tells you what you do. Price per bottle. So this one is $15.50 to a 24 pack. This is $8.15 to a 12 pack. Divide them out. Just get your unit rate on each of them to find out which one's better. You say $15.50 divided by, what was it, 24? Oh, I did. I just can't aim straight right now. We're that cross-eyed. 15.50 divided by 24 is, so about 65 cents a bottle versus 8.15 divided by 12 is about 68 cents per bottle. It's not that much of a difference, but 3 cents a bottle, what happens if you regularly go through a distributor like that? If it's the exact same thing and it's 3 cents less a bottle and you're buying, 40,000 of them over the course of a year, well, then that makes a difference, okay? But it was just unit rates. Unit rates is X per 1 Y. Okay? How many of these per one of those? In this case, dollar per bottle. Y'all notice those when you go to the grocery stores? Like on each of the labels, they'll say so many cents per ounce. They'll say so many dollars per count or whatever. Those unit rates, those weren't always there. You back up about 20 years and you'd have nerds like me who were just standing there in the grocery aisle staring at it thinking, nah, divided by 6, carry the 1, okay, this one's a better deal. Well, then they just started printing them on the labels. Yes? 36? 46. 36 or 46?
46.
Okay. I'm writing an equation in slope-intercept form of something going through 0.52, 4.53. Which would actually be a really good warm-up for today. Because on our trend lines, we make the graph, we do the scatter plot, we make a line that's kind of through the middle of it, fits our 3 rules, and then we'll get 2 points. You have to be able to make a line with these 2 points. Step 1 is always to find the slope. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. There's even a little song for it, but I can't sing worth. Nope, not happening. So, I'll label the first x, the first y, the second x, the second y. I use a bunch of parentheses, okay, butt cheek, butt cheek. You put the parentheses there because they're going to help us to not screw up negatives. I will plug in those values, y2 y1, x2, x1. Now we might get a little scared because there's decimals in there, but it turns out the decimals lined up nicely. When you subtract, you get your slope of 3 minus 2 is 1, 4.5 minus 0.5 is 4. It's just a slope of 4. Now, your next stage kind of depends on your personal preference. You're going to plug into either y equals mx plus b, or y minus y1 is m by x minus x1. What's your preference? I'll do the other one, but which one do you want to start with? Okay. So you start with, I know a slope. I just found it. 1/4. I also have two xy pairs up there, and you get your choice of which one you want to use. Smaller numbers, right? Easier to work with. So I'll put 0.5 here, and I'll put 2 here. So I got to clean that up. 1/4 times 0.5. Or better yet, fractions from just now. 1/4 times 1/2. Right? 0.5, 1/2. Multiply straight across. 1 by 1 is 1. 4 by 2 is
1/8.
It happens. So 2 is 1/8 plus b. Get b all by his lonesome. Subtract 1/8. Now, when you do, okay, I'm kind of forcing the issue with fractions here. If you want to go to decimal town, you can. This is a terminating decimal. We've talked in here before about precedent. You set the precedent. You all know that in an argument with your parents, you don't bring up thing. Because as soon as you bring up thing, they can now attack thing, right? Well, you let so-and-so go, and then they're like, oh, that's right, and then they start yelling at your brother. And now your brother's mad because you ratted them out, and there's a whole big kerfuffle and all that. Like, there's that precedent that something can be used if it is brought up. They brought up decimals, so it's perfectly legal for you to go to decimal town if you want. If I take 2 minus 1/8, I get 1.825 or 885. I don't know. I can't mental math here. Why do we not have calculators in front of us? Okay, I did take them away earlier, so yes, bring them back out now.
What did you say?
You have to subtract to get b by itself. What is 2 minus 1/8?
15.
What is that as a decimal? If I had chosen, instead of 2 equals 1/8 plus b, did you say 2 equals 0.5 times 0.25 would be 0.125, right?
1.875.
So either you get b is 1.875, or you get b is 15 sixteenths. No, 15/8. The reason that I am personally not a fan of going that route, how many times do we get b and then we just quit? We forget. But if you remember to put the parts back together at the end to say either y is, my slope was 1/4, could I have said 0.25? X plus 1.875? Or in fraction town, y is 1/4 x plus 15/8. That's a really sad 8. It's like it got stepped on. Okay. Either one of those works. Again, if you go point slope, I'm a lot more of a fan of that personally, but that's me because I actually like fractions. And everything's nice in one spot now. Y minus 2 is 1/4 x minus 1/8. Add 2 to the other side, and you get those same things. Okay? Either one. Why are you up here, Joe?
Because I can't see very well back there.
Why is 11 weeks into the term the first I'm hearing of that?
Because I don't know.
Contain yourselves or someone's moving. Either one of those. You have to be able to make a line from 2 points. Have to. Because that's also what 5/7 is about. Okay, I said we were very close to done. Did we finish Baby Panda?
No.
I know we were working on Chunky Panda. Were we working on Short Panda?
No.
Okay, so we haven't done Short Panda yet. All right. Well, stage 1. Can you make a scatter plot? Okay, that's where we left off. I'll walk you through the steps once we've got the scatter plot on, but making a scatter plot of data is something that we've done several times in here. Like all the way back through chapter 4. So, can you make an appropriate scale? You've got 10 boxes in each direction. You have age 1 through 9 and body length 8 through 29. Do you have enough room to do what you want to do? You got to make an appropriate scale. You might not have the same scale as your neighbor. Although if you want to compare notes, might not be a bad idea to get the same scale as your neighbor before you start plotting. Well, it should be roughly linear. Right? They're not going to have us make a model if there's no correlation to it. Now, how good of a model it is, well, it depends on how close your points line up. Sometimes it's almost a perfect line anyway. Other times, not so much. Okay, it looks like most of us are there finishing up. I'm betting most of us got, here, I can fit that, right? Yeah, we can. I'm betting most of us said age in months and just went by ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What did we use for a scale on body length? How tall it is. Okay, I've got 10 boxes. Will going by fives fit all my data? Yeah, it will. Anyone choose something different? Ooh, I heard a couple say threes.
I did the lightning bolt thing, and then I went by fours.
Okay, the lightning bolt, y'all remember that? That little break that says I can start at a certain place? So all of those are valid. Like, they all work. I like it. I heard several people say threes, so I'm actually going to go by that. But all of those are valid. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. 30. Right about when your knees start making noises. Body length. Oh, I'm not talking about just little noises. This is in inches. I want you to think about that. Baby panda, 30 inches. I don't like that. That's adorable. That's a little panda. It's just like a little fluff ball that just sits there and eats all day. That's adorable. It's my kid. Okay. Start plotting points. 1, 8. About 2/3 of the way. 2, 11.75, almost on the 12. 3, 15.5, just a hair off of the line. 4, 16.7, almost 2/3. 5, 20.1, about 2/3 of the way again. 6, 22 and change, about 1/3 of the way. 7, oh, we don't have a 7. 8, 26, 5, 24, 25, 26, 5, and 9, 29. Double check me. Said I can hardly see straight right now. Okay. Do you remember what our rules were to making the line? What?
The numbers on the right and the amount on the left.
Want to try to go straight down the middle for whatever the general trend or ratio is. I want to make sure there's about the same number of points left and right. And I want to hit at least 2 points. Now these are almost perfectly in a line. So how I make my line, I kind of want to do, what do you think? See, the way that I ended my line, I actually ended up with 3 on the bottom, 1 on top, but I hit a lot of points. Should I have wiggled it a little bit? Should I have maybe wiggled it so I hit this point and those points? Right? It's 2 at a minimum. Well, one of them has 3 points below, the other had like 4 above. They're still going to be really close. And this is where you got to remember that what you have and what your neighbor have might not be the same thing. That's okay as long as at the end we're pretty close. So at this point, I might be off-road of where you are, but what I'm going to choose is that line there. I'm going to go through this point, which is 211.75. I'm going to go through this point, which is at 622.2. That might not be what you had, what you chose for your line, and that's okay. You follow the process with whatever 2 points you are using. Because now I make a line with the 2 points. Step 1, make a slope. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It's a really bad parenthesis. Okay, I'm going to label first x, first y, second x, second y. Say 22.2. I need to make those bigger. There we go. That's better. 22.2 minus 11.75. 6 minus 2 is he said 10.45? Yeah. Okay. So if I have 10.45 over 4, well, that's a terminating decimal. They gave me data in decimals. It's okay for me to go to decimal town. Divide now. 10.45 divided by 4 should be about
0.61.
the decimal train will stop, so go all the way. 2.6125. Okay? Because it actually ends, I'm going to write the whole thing. Now, if it kept going forever, then I would have cut it off at 3 places anyway. But because it stops, I'm going to use it. So I got a slope. A Y-intercept comes next. I can either go y equals mx plus b, or y minus y1 is m by x minus x1. I don't care which you use. If I use this one, I'll choose whichever of the points. I'm actually going to use this guy just because the decimals on it are smaller. And say y, 22.2, is m, 2.6125, x, 6, plus b. I multiply. So it's at 5, 30, 0, 3, 12, 18, 5, 1, 6, 7, 6, 36, 3, 12, 15. 15.675? Question mark? Okay. Never mental math on 3 hours of sleep. Bad news. And then subtract. What's that? 7, 6, 6, 2, 325, 525, 6.325? No, 6.525. Someone help me out. Press the magic buttons. Help me, freshman one Kenobi.
6.525 is what I got.
That's what I said, I win. 6.525. Yeah. Or, option 2, y minus y1, m, 2.6125 by x minus x1, 6. But then you're just going to distribute and add that over anyway, and you'll get the exact same thing, which is My equation ended up as 2.6125x plus 6.525. I know. If you use different points, you will not get that exact answer, but you're going to get pretty close. Did you get around 2.5 to 2.7? Somewhere in there for a slope?
Yeah, I got the.
Ooh, fractions. Well, poke your convert button at the bottom right corner and switch it over, or wait, that's Casio, SD button. Swap it over to a decimal so we can directly compare. On the Casios, you should have SD. Poke.
Holy sh.
Ooh, 1.8 something. That's a little too far off. 2.625. That was almost perfect of what we had here. So ours were very close.
I did different points too.
2.6125 and 16 points. Whoa.
Yeah, I did different.
16 points on that ain't right. 5.2 and 11.75. Oh, because this will be negative.
Oh,
And then when you add it over.
never mind.
Okay, so we're good. You're just like, you all right? Okay. Yay, nay, different points, or just use these ones? Okay. So that's the thing behind it, is whatever points you use, you should get kind of close to this. If I'm looking at this on, I don't know, a test on Monday, I'm looking for the scale. The points are plotted. You found your slope using two of the points that were kind of halfway decent. You plugged stuff in, and then I'm going to look at your slope and your y-intercept for your end equation, and I just want to see that they're kind of close. I would take probably all the way down to like 2.3 through 2.9 for a slope. You know, about 0.3, about a third on either side. For your y-intercept, if you're somewhere between about 5 and 8, I'd probably take it. Because your points, it's just as much about can you do the math behind it after choosing your points. If you find your equation perfectly, but you just chose different points than someone else, that is okay. So that's something that we need to practice. Okay? Because that's what your assignment is. We'll have time in class to work on it, but down at the bottom, before we do that one, right above that, were you all good with that whole positive, negative, no correlation thing? It's just positive slope, negative slope, buckshot, right? Okay, so down at the bottom here, the table shows number of students per computer and wow. This is an old book. You want to know how old this book is? The data that they're working with here. So usually the end data that they put in these tables, they use that as this is the last data that I collected before I published it. So this book was probably published 2008, 2009, which means 12 years or more. And even then, they probably reused problems or data from before. Y'all, 96, I was in 6th grade. Yeah. Anyway, back in the ancient times, we used to have computer labs. There was no cart that came to your classroom. There was no laptops. Are you kidding? That's what like big CEOs and fancy pants have. Okay? You went down to the computer lab and you went into your assigned computer and you had to check in there like once every week or so. You got your scheduled time and yeah, it was something. Um, can you put that in? Can you make a reasonable scale that goes from highest to lowest? What I'm going to tell you, and we ran across this before, don't just use the years. Don't like put 1996, 98, 2000 at the bottom. Instead, you pick a year and you'll say X is years since what? That way, I'm not putting gigantic numbers into my equation. I'm not putting 1,998 into my equation. Okay? I know you don't like big numbers. So, where do you want to start? Do you want to start at 1996? Do you want to go back further and say 1990? Do you want to just use the last two digits and say since 1900 so you can put in 96, 98 to 100? What do you want to do? 96? It's usually the easiest one is to just start at 0. So instead we're going to call this 0, 2, 4, 6, 8, 10, 12. And boy, that makes it a lot easier. All right. Now that we got that out of the way, make your scatter plot. Make your scatter plot. Get your trend line. Get close enough. And then go write your equation from the 2 points that you chose. Not a bad idea to buddy up with someone to make sure that you're kind of on the right path. Nope, 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 not doing it. I want to see what you come up with first. Get a reasonable scale. Plot your points. Make a trend line that looks decent. Once you have your trend line, can you make the equation? In fact, once you have the trend line and you have your 2 points, it's the same thing we've been doing for 3 weeks now. This also be a great note to write to yourself, although I know we've seen it before. Define your variables. Put X is years since this. Y is students per computer. And notice the trend on it was going down to the point where now, even at the middle school, you've probably been one-to-one laptops since leaving elementary. What's up? Well, it will go down like that, yeah.
So I went by 5.5 because I saw it work.
Okay, if it works, it works. Wow, are we going all the way up to 55? We only need to go up to 22. Oh, well, I mean, it still fits, right?
Mm-hmm.
Whatever, it fits. And you went by this? Okay. Your scales look good. Make sure that you actually put what they mean on there, too. Remember, don't just put numbers for a scale. Put the labels. And people who've been in my class before, they get real nervous when I come up to them and say, hey, Peyton, do you want 5?
What?
Do you want 5?
Sure.
All right, 5 detentions. We'll sign you up. We'll get scheduled for all next week. You'll be good to go. Okay? And I come up to Aiden and I say, hey, Aiden, you want 5?
Yeah.
He does? Oh, Aiden gets Pop-Tarts. 5 Pop-Tarts. Okay? Like, the label on it matters, right? So don't just have numbers on the side. You want words. What do the numbers mean? Yes. Okay. Got a nice downward trend. Slightly off-road, and that works. Looks good, looks good, looks good. We found a slope. Your slope ended up nice. Ta-da!
Right on.
There you go.
I wasn't here last class, sorry.
What's 4 divided by 2? Reduce, reduce, reduce. But yes. Looks good. Okay, looks like most of us got at least our line and are working on the equation. So I want to get at least mine up here and some scale to it. Poke, poke, poke. X-axis. Peyton, what'd you go with? By 3s? Okay, I'm just going with it. Okay. Did anyone go by 1s and just go off-road? Because you'd have 10, 12. Okay. That's only 1 box off-road. I'd take it. Okay, I like 2s though. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And that is years since 1996. And, okay, Dominic, what'd you use for your vertical scale?
5.5.
5.5. Will it fit? 10 times 5.5 is 55. Will I fit all my data? Well, yeah. All right, I'm doing it. 0, 5.5, 11. 16.5, 22. 27.5, 33. 38.5, 44. 49.5, 55. I forget who I was working with the other day. It was yesterday. Someone came in for a test. And I was kind of doing that as we were going through the review, and I was only labeling every other one. They said, wait, you can do that? Yeah, you can. If you label every other one, and you see that it takes 2 boxes to get to 11, you know what each box is worth, right? Divide by 2. So I'm going to use that because that's what Dominic used. You don't like it? Blame Dominic. I'm going to say that students per computer. Go plot a bunch of my points and say 0, 22, poke, 2, 18. God, now that's annoying though. I don't like it. I blame Dominic. We can still figure it out though. 4, 14, so that's about here, 6, 10, about here, 8, 6.1, there, 10, 5.4, about mere, 12, 4.9, Rutrow. You see how it kind of started curving at the end? That means it's not perfectly linear, and that's okay. I'm going to make a trend line that kind of cuts through the middle of it. I like this idea of like right smack through there. And I personally am going to use this point. What's that? 218. And this point, which is 10, 5.4. That's what I'm using. Doesn't have to be what you use. Find your slope. 5.4 minus 18 over 10 minus 2. Orange. There we go. 15, 13, 12.6 over 8 is 5, 3, 3.75? 30.75. No. 3.75. Check it. I don't trust myself. 12.6 divided by 8.
1.575.
Samsonite. Y'all are so young, you don't even understand what that's from, do you? You probably do. No? Oh. I thought you were the one who adored 90s pop culture. You ever seen Dumb and Dumber? Original Dumb and Dumber, not the new ones. Okay. It's a good movie. It's got to be free on YouTube or Netflix or something. Like, just watch it. It's good. Not at school. I got a slope. Y is mx plus b. I remember a lot of you really liked I don't want to use decimals, or I don't want to use point slope if I don't have to. So I'll plug in 18. My slope was 1.575. X was 2 plus b. 18 is 3.125? 3.15. Subtract, and I get B is 14.85. So I got something that probably isn't what you got. But if I have about 1.575x plus 14.85, is it kind of close to what you had? I missed a negative. I missed a negative. I missed a negative. I missed a negative. You could have had the free brownie point. Negative 1.575x plus 21.15. That a little closer to what you had? Okay. I saw some of us were anywhere between negative 1.4 and I think I saw someone all the way up to like negative 2.1, 2.2. Kind of depended which points you had. Do you have a negative slope somewhere between 1.5 and 2.5? Do you have a Y-intercept that's somewhere between, I don't know, 18 and 24? Then you're good. Okay? Trend lines are not perfect. Perfection comes when you use a calculator. And I don't really feel confident running through the calculator stuff with you. I would rather that we know how to do this manually because the calculator has its own pitfalls. Also, what's the point of showing you how to do linear regression on a calculator when it's the only thing you're going to use a graphing calculator for in this class? Okay? So, last thing. Identifying whether a relationship is causal. Causal. What do you think that means? Hmm. Oh, all right. What word do you hear in causal? It causes it. Okay, does one cause the other? Joe kicks Aiden in the shins. Aiden starts crying. It hurt. One caused the other, right? This action causes that action. They're asking, is there a correlation between them? Like, there's a difference between correlation and causation. I told you about the really stupid correlation graphs where you can find like the number of, I don't know, the number of twin births in Miami, Florida corresponds exactly to the number of new fire hydrants put in Fargo, North Dakota. Like, the graph matches, but they have nothing to do with each other. That's what we're asking here. Well, maybe they redid all the streets. I don't know. Did that in my grandpa's hometown. They've been working for the last 2 years, tearing apart and resurfacing and resewering every single street that has been there for the last 130 years. Boy, it's taken them a while. Just tell me, is there a correlation? Does one cause the other? The number of loaves of bread baked and the amount of flour used. Is there a correlation? Is there a cause?
Yes, the flour caused bread.
In the order that they said? Okay. So there would be correlation, but does the number of loaves I bake determine the amount of flour the number of flour used? Yes, that is direct correlation and causation. The more the more bread I'm baking causes me to use up more flour. So, is there a correlation? Yes. If so, does it reflect causal relationship? Yes, the amount of bread that I bake causes me to use flour. B, the number of mailboxes and the number of firefighters in a city. Unless you got one pyro who's just really, really into lighting mailboxes on fire, no, those have nothing to do with each other. So I'd say there's no correlation, and one definitely does not cause the other. I don't know. I think Joe might light things on fire. You seem like slight pyro vibe. Like this much. I was. I was an only child on a farm. Nearest friend was like 8 miles away on a four-wheeler. Yeah, I learned how to make improvised explosives. That was my thing. Oops. Thankfully, I grew up in the age before Googling how to make Claymore mines got you a visit from the FBI. So, the bottom two. Tell me, is that a correlation? Will one cause the other? They won't necessarily be yes, yes, no, no. You might have a yes, no. You might have a no, yes. Can you tell me, is there a correlation? Does one cause the other? Now you have to be able to not just write the words yes and no. It does say explain. Can you tell me why it does or does not? I ain't looking for a dissertation. As long as you got a sentence that kind of makes sense, we're okay. The cost of a family's vacation and the size of their house. Do you think there could be a correlation between those two? Does it make sense that someone who spends more money on vacations might have a bigger or smaller house? Yeah. If you've got more money to spend on vacation, you probably have more money to spend on big house. Okay? Cough, cough. Spearfish. Does one cause the other, though? No. Okay? Not at all. Because, well, the cost of the vacation. Maybe they just saved up for like 10 years. Maybe they do cheapo vacations and they got a big house because they got 8 kids. They probably don't go on expensive vacations if they got 8 kids. Guess what? Kids are expensive. A single diaper is like somewhere between 68 cents and $1.25, depending on the size and the brand. You know what happens when a kid goes through 12 diapers a day for 2.5 years? That's a lot of money. Time spent exercising and the number of calories burned. A double yes, right? There will be a correlation between them. Case in point, I don't sleep. So that's why I put on 60 pounds in the last 3 years. Baby bear won't let me sleep. I'm exhausted. I don't have energy to go exercise. Also don't have time because I have to work. Number of calories burned. Well, the less you exercise, the less you're going to burn. The more you exercise, the more you're going to burn. Before goblin number 2, we were up every day at 5 a.m., head to the rec center and go lift weights for a few hours before school. It's great. It is a double yes because the amount you do of this affects the amount of that. You have to be able to put that in a sentence. I'm cutting off there. You're not going to have a lot of problems on the assignment, but expect that you are going to do, I got to double check the book here, 2 or 3 of these make a scatter plot, give me the equation. Once you have the equation, are you okay using it to predict? Like that last one was, what was that last one? The year and the number of computers or students per computer. If I then said, okay, now predict what happened in the year 2016. Well, how many years since 1996 was 2016? Take 2016 minus 1996. Yes. So I just put 20 in for X.
Oh, yeah.
Ta-da! Done. right? So you can use the model once you have it to predict. If we're looking at how big is baby panda bear, well, now that I got a model, I can say, okay, what about when he's 28 months old? Holy smokes, that's a big bear. So let's look at, I got to throw it all on plan book. Yes, it's work time. We're going to go page 341. Because we didn't do the graphing calculator thing. Two are make the scatter plot and make the line. The other four are words. Tell me, what kind of correlation is there? Is it causal? Okay, so you only have to make two graphs with two equations. I've said it enough times, we're more than halfway through the semester. Get yourself some graph paper. Okay, some of you, your graphs are just nasty. Okay, there's graph paper right up there. There is no excuse for you to be doing this on line paper. Do it for real. Use a straight edge. Try to make it kind of neat.